Hi, and welcome to this video on identifying solutions to an inequality. Okay, so we're going to do this little exercise here, and it says state which points are solutions to the system of inequalities graphed below. Well, we can see that we have two inequalities graphed, and in both cases, they both have solid lines, and this one is shaded above, right, whatever this line is, and this one has a solid line, and it's shaded below whatever that line is, right? So we can see our overlapping region is right in here. So any points in this region and actually on the boundary lines would be part of our solutions. So let's look at it. We have the point 0, 0. Well, 0, 0 is on one boundary line, but it doesn't satisfy the both inequalities, so it's a no. Now let's look at 2, 2. The point 2, 1, 2, 1, 2. It is on the boundary of the region, and so yes, it does satisfy, okay, because that boundary is included in our solution region. Now let's look at the point negative 1, 4. Negative 1, 4, 1, 2, 3, 4 would be right here. Well, that's in one region, but it's not in both regions. So this will be a no. And then the point 4, 1, 1, 2, 3, 4, 1. Yes, that one's actually in our region. And then negative 3.5, about right here, and negative 1.5. Well, no, that's in the white region. It doesn't satisfy either. So that would be a no. Okay, the other thing we need to understand how to do is to find out whether a point is a solution to a system of inequalities. Well, what does that mean? Well, that means it has to make both inequalities true. So this one and this one. So let's test it out. The point negative 3, 6, test negative 3, 6. Okay. All right, so this is the second exercise. So 3 times our y, which is 6, is greater than or equal to negative 6 times negative 3 minus 9. So let's simplify that. 18 is greater than or equal to 18 minus 9. So that's positive 18. So 18 is greater than or equal to, well, 18 minus 9 is 9. Okay, so it works for the first one. Now we have to check it in the second one, because if it doesn't work there, then it can't be a solution. 6 is less than or equal to 3 times negative 3 plus 6. So in this case, 6 is less than or equal to, this will be negative 9 plus 6. And so that's 6 is less than or equal to negative 3. Okay, so let's make sure we did our math correctly. We put 6 in, well, we put in negative 3 for x, and then plus 6 for y. So that's negative 9, that's right. And then negative 9 plus 6 is negative 3, and 6 is not less than negative 3, so no. So the answer to this question is negative 3, 6 a solution to the system of inequalities? The answer would be no. Okay? All right, so remember that you have to test as we did over here. Okay, so this gave us our answer. That's our proof that it's not a solution. Okay, so you don't need to try to create a graph and all of that. You can always just plug the point in and test it algebraically. All right, I hope this has been a helpful extension of the types of things that you should be looking for and that you should know when solving inequalities. And there are a couple of practice problems that you can do here. So you have solve each inequality by graphing. You have some problems that you can do here. Actually, let's do one of them together. Okay, let's do number 3, because I know some of you have questions on what to do when you see this. Okay, well, right now, because you don't see an x and a y in both equations, you automatically think, oh, well, is this a number line? Well, no, you're still graphing it on the graph. Okay, remember that these are special cases, a special line. So if I have y is less than x, that's the boundary is the line y equals 1. Y is less than 1. The boundary is the line y equals 1. So what that means is that all my y values are 1. So starting with the y-intercept, 0, 1, all of the y values are 1. So what does that create? Well, that creates a horizontal line, and it's going to be a dashed line, right, according to what I know about inequalities, okay, signifying that the solutions on the line are not included, okay, and then it's telling me that I'm shading below because it's less than, so let's go ahead and do that. So I am going to shade below, and let me move up a little bit. Okay, so I'm shading below. And then I have x is less than 1. So x is less than 1. That means that on the x-axis, this would be kind of like the line x equals 1. So it's a vertical line at x equals 1. So on the x-axis, x is 1. But also everywhere else, x is also 1. So what I get is a vertical line on on x is equal to 1, and it's a dashed line just like the other one, and because it's less than, it's also not included. The boundary is also not included in the solution, so that makes a dashed line. And then it's going to be, remember the special case of x is where when you shade less than x, it's the only one that's vertical. And so remember that even on your number line, your solutions get bigger for x to the right, and they get smaller for x to the left. So if it's less than 1, it's values that are smaller than 1. And so we're going to shade to the left because we want the value smaller than 1. Okay, so for this particular problem, our solution region is overlapping. It looks like starting just above the third quadrant. So in the second quadrant and the third quadrant is where most of our solutions lie. Okay. All right, so if we were to pick a point and test it, we could test any point. So let's try -1, -1. So if I plug those in, I'm going to plug them in here because I'm kind of running out of room. Y is less than -1. Well, y is -1 here. So -1, if I plug that in, -1 is less than 1. That's true. And then let's plug in the x. X is -1 here also, so -1 is less than 1. That's true as well. So that point satisfies both, okay? I could also use 0, 0, because that's actually in my region. 0, 0, 0 is less than 1, and 0 is less than 1, so that would work too. Now, if I picked a point here, or here, or here, none of those would work because they're not in my region. And also, the boundary intersection point, 1, 1 would not work. 1 is not less than 1, and 1 is not less than 1 for x either. And so those points wouldn't work because they are not included in my solution region. Okay, so I hope this video has helped and gone into more explanation. I recommend that you continue the exercises below, that you figure out how to write a system of equations from the graph by looking at the slope of the boundary and the y-intercept of the boundary and forming your line, and then also choosing solution regions. Okay, I hope this has helped. I'll see you in the next video.